Hi, everybody. People are still joining, but I think we may as well get started now. And hopefully you can all hear me. So good afternoon, everybody. So I'm Ranil Sonnadara. I'm the president for Compute Ontario, and I am one of your hosts for this event today. Before I begin, I think I would like to just acknowledge and recognize that I'm speaking to you today from the traditional territories of the Mississauga and Haudenosaunee nations, and within the lands protected by the Dish with One Spoon Wampum Agreement. I welcome all of you to the event, and we're really pleased that you could join us today. So I think first up, we'll just do a quick review of the agenda. So in about 10 minutes or so, Tibor Turi from SOSCP will be starting us off. And then at 1:30, we'll have a keynote address from Charles Nyabeze from the Center for Excellence in Mining Innovation. Around about 1:55 or so, we'll be doing a moderated question and answer session. And then we'll probably wrap things up around 2:30 or so. A couple of quick housekeeping notes for everybody. We are going to be recording the session, and we will be making it available for all attendees today. And if you can make use of the chat function for general comments and questions, we'll be monitoring this, and we'll ask our speakers to respond in the question and answer session at the end. And the chat function will just allow you to drop your questions in as they come up. So please make use of that facility. So my role this afternoon is to give you a bit of a brief orientation to advanced computing and the ecosystem that supports it in Canada. So today I'll be speaking to you mainly about an Ontario perspective, and in future sessions you'll have the opportunity to learn more about the ecosystem as it sort of is really focused from the Atlantic region and also in Quebec. So we have a really diverse group of people here today, and so I thought it might be helpful just to start at the beginning with a quick talk about what do we mean by advanced computing. Advanced computing is a term that gets thrown around a lot. It means different people to different things to different people. So when we're talking about it today, what I'm really talking about is any kind of computing you might want to do that you couldn't do on your typical desktop or on your typical laptop. So for some folks, that might mean parallel computing. You might be talking about high-performance computing or supercomputing. We might be talking about big data. Might be talking about data analytics, data visualization. Might even just be talking about storing enormous amounts of data that you just couldn't fit on your hard drives typically. Often we use sort of more advanced computing for doing things like machine learning, data analytics, and artificial intelligence. And researchers tend to use these sort of powerful tools to turn raw data into knowledge breakthroughs and solve real issues that we face. Industries tend to use advanced computing for automating manufacturing, combating hacking, accelerating software development, and in mining, advanced computing is often used things like autonomous vehicles, environmental monitoring, impact analysis, targeting drills, and ore reserve forecasting. We'll be hearing about all these other uses a little bit later today. So there's a really complex ecosystem that's involved in delivering advanced computing. And because I live in a world which has research as its primary focus, advanced computing is often known also as digital research infrastructure. And that's DRI. It's a term that encompasses hardware, data management, software, skills training, infrastructure such as high-speed networks, and also critically the people that can make all the pieces work together so that we can all leverage this technology. And this slide kind of gives a bit of a simplified view of who does what in the ecosystem. So starting on the left, funding. Advanced computing is expensive. And so a lot of the funding for the DRI platform in Canada, at least the national platform, comes through ISED, which is the Innovation, Science and Economic Development Agency. So they provide a lot of the funding, but then there's also significant funding that's provided by provincial matching contributions and also by some institutions as well. So it's a federated funding model, which reflects the federated nature of the ecosystem. In terms of strategy, investment, and coordination, because it is a federation, a lot of effort is required for actually coordinating all the events. So a lot of this work is done by an organization known as the Digital Research Alliance of Canada, and there are also regional organizations across the country as well. So starting from the east, we have AceNet, and then we have CACO Quebec in Quebec, Compute Ontario for Ontario, and everything west of Ontario is currently served by an organization that's known as WestGrid. In terms of how you access services, there are a lot of individual academic institutions and academic consortia that provide the computational power and the expertise to researchers, and this gets coordinated through the National DRI platform. There are also some mixed consortia which comprise both industry and academic members, and they provide computing power and expertise to industry and also link that industry with the academic experts. So examples of these organizations would be SOSCP, ACENET, and PINC. The ecosystem also includes research institutes, we have university and college libraries, and lots of enabling services such as high-speed networks as well. And there's a lot of collaboration amongst academic researchers and industry, including in the oil, gas, and mining sectors. And several of the regional agencies and the consortia that are on this slide are actually going to be your co-hosts for today. You'll have the chance to chat with many of them. So each of our organizations has a slightly different business model and a slightly different mandate, but all of us support research and innovation in some sort of fashion. And we all have a strong interest in supporting the mining sector in Canada. And we felt like this event we'd have a much bigger impact by partnering for this set of workshops and then opening up to the whole country rather than working individually in our respective regions. And so COVID, for all of the chaos that it's brought, has really helped us to embrace the spirit of virtual meetings. And so by leveraging sort of what we've learned over the last little while at running these kind of events, we thought that we could have a much more powerful and hopefully a much more useful event, which will get some really interesting conversations started here today. So just very briefly, Compute Ontario, we're funded in Ontario by the Ministry of Colleges and Universities, and our role is to kind of really deal with strategy and bringing together provincial and federal investments for Ontario's DRI ecosystem. ACENET supports Atlantic Canada, and they provide infrastructure and also a team of research experts that can really support training and delivery of ARC systems to academic, government, and industry users. Calcul Quebec does a similar sort of function within Quebec. And in Quebec, we also have PINC, which is focused on digital innovation through collaboration between academia and industry. And SOSCP plays a similar function, bridging the academy and industry in Ontario as well. And I should note that we have Michelle Fash from ACENET and Eric Capel from PINC as part of the audience today, and they would be delighted to answer questions and talk further about what they do. So if you're in Atlantic Canada or Quebec, don't hesitate to reach out to them. And of course, in Ontario, we have Tibor, who will be talking to you in just a second. And we will provide you with some contact information for everybody as well. And speaking of Tibor, I think I will now hand over to you. So Tibor Turi is the Executive Director of SOSCP, and he'll tell you a little bit more about the work that SOSCP does and how advanced computing fits into the way that we're thinking about industry and academic collaboration. Tibor brings a lot of experience with academic research, industry, and global R&D, and is really sort of focused on the innovation side of things. Tibor, over to you.
Thank you very much, Ranil. Thanks for the initial presentation and for handing off the mic. I have the benefit of seeing each other face to face. So thank you very much for those for participating in those two. Right now, I'd like to give a presentation a bit about SOSCP. I was mentioned earlier a little bit about SOSCP, but I want to give you a bit more in-depth cross-section of who we are. So SOSCP was launched way back 10 years ago. We're celebrating our 10th anniversary this year. It was a collaboration between Ontario academic institutions, FedDev, IBM Canada, and SMEs across the province. So the idea was and still is to bring together academic and industry expertise, all about addressing the innovation gap in Canada, and specifically giving SMEs access to the right technology and the right expertise in order to address various real-world problems. So SOSCP has, in the time we've been around, we've established a collaborative ecosystem, helping to accelerate economic impact, job creation, and skills retention. So this is the real reason that SOSCP was put together, that last bullet there. Next slide. So our mission, still as relevant today as it was on day one, is to bring together these industrial partners, big and small, and academic researchers, the experts, provide them with sophisticated advanced computing technologies and expertise to solve the social, technical, and business challenges across sectors. And the intent here is to drive economic growth. So this mission is founded on the belief that data science, education, training, and research can and does improve the way Canadians live and work. And I believe that's more than borne out by much data. Next. Okay, let's talk about what we do. So we are Canada's leading research consortium, bringing advanced computing directly to industry and to companies who need them, who want to adopt them. And we build these partnerships in-house with our own business development partnership function, industry and academic partners alike, to solve industry challenges. We're not here as an academic support, we're here as an industry support to align tools and funding and to ensure the success of whatever projects we take on to our resources and our systems. Next. And the outcomes, there's 5 principal pillars of outcomes: commercializing new products, services, improving business processes, increasing sales at companies, creating new jobs at those companies, and taking advantage of the talent, helping to train that talent, and ultimately growing companies. The ultimate holy grail being export and scaling up of those companies. Next. So here's a couple of perspectives of what we do when we look at a bit of the nuts and bolts. So we support all the components of a successful industry-driven research collaboration, whether it's the actual computing technology itself, the software and the tools that you need, the technology experts that you may need. We also provide partnership support and access to HQP and connections to funding and commercialization ultimately at the end. Next. We go to the next slide. Yep. So the second perspective has to do with driving industrial growth. So from this industrial perspective, we're all about supporting industry, develop new product services, improving their business processes, solving problems that they may have, creating the jobs that you need now and into the future in your organization, bringing Canadian products and services that you have to market, and ultimately to share the results. Yes, indeed. Okay, I'd like to touch on advanced computing once more again, as there's a lot of jargon in this sector, and can get very confusing, especially for the debutante. Let's try to boil this down and talk about what advanced computing is as an umbrella term and what we mean by advanced computing. So basically, it's much more than your laptop, or whatever your laptop can do, and the programs and the apps you may have. This is beyond that, well beyond that. So it's a combination of computer hardware, the actual equipment, and also how you use it. So here's just a short list of some of the terminology that may also apply, that may be included under advanced computing. So everybody's heard of supercomputers. So supercomputing itself can be referred to as high performance computing, HPC. There's machine learning, artificial intelligence, data visualization, visualizing large amounts of data, representing it in ways we can understand. Of course, there's big data, massive amounts of information, and data mining, how we look at that information, something that was up until now impossible to really see without the help of advanced computing. Cloud analytics, data analytics, deep learning, virtual twinning as a concept to bring into the digital world something that lies outside of it. Natural language processing is gaining ground. Smart computing, and on. We could talk about all these jargons, but ultimately advanced computing is an umbrella term where you can have access to any one of those that may fit your particular need. Okay. So why do we need it? Now that we know what it is, let's boil it down to 4 simple areas. So first, the problems that you have and that you're trying to solve are just too big. So you need more memory than your regular laptop can handle, significantly more memory to solve some kinds of problems. The data is too big, especially in big data problems. You need more storage. You just can't put the data someplace where you can manage it and manipulate it and work with it. So the data is too big. You need more storage. Problems take too long. You need faster results. or the problems are just simply so complex that you need more and faster computations. If you have a need in one or more of those, you are a candidate for advanced computing. Next. SOSCP itself, we do have our own facilities, our own hardware. We have 3 different platforms. The Cloud Analytics platform, Canada's only dedicated cloud analytics platform for industry applications and use. We also have, as our crown jewel, our CPU accelerated platform, where we do deep learning and simulations of all different kinds. Also parallel CPU platform, a more traditional kind of CPU technology, but nonetheless very good for doing many different types of problem solving and computation. Those are our 3 platforms. And what do you put on those platforms? Well, you do project work, and the project development looks something like this at SOSCP. When you look at the partnership services we provide off the top, on the one hand, you may have an industry partner or partners, an SME, a startup, multinational, whatever it may be, one or more of them with a specific defined challenge, and that's critical. Along with a contribution comes along. And on the right side, I have academic partner or partners or post-secondary partners, if you happen to be working with a college, with the expertise and talent that's needed in order to engage with the project. You bring those together with leveraged funding from existing organizations, perhaps outside, like MITAX, like NSERC, OCI, like Scale AI, various other sources of funding to inject into the project. And then SOSCP can provide advanced computing resources and technical support in order to engage with approved projects to provide and generate positive outcomes and trained, highly qualified personnel out on the other side, often capable of being hired by the same organizations. And that's one of the great outcomes we have at SOSCP. That's what the project development cycle looks like. Next. Our SOSCP community looks something like this. We have ecosystem partners, some of which are funders, but they include government. They include partners that are listed here. Of course, we do have other partners as well, but this gives you an idea of where we play. And of course, we have our all-important members. We have institutional members, 18 of them, universities, and now 5 different colleges, as well as industry members, cornerstone partner IBM, the first one. To that, we've added Loblaw Companies Limited, Unilever Canada, and Nuclear Innovation Institute, and DARE, which is the Downsview Aerospace Innovation and Research Hub, both of which come with a cohort of their own companies. So that's what the community looks like at the moment. And next slide. Our impact, what has all this produced? Well, quite a bit, actually. So far, SOSCP, we've engaged over 170 different companies in collaborative R&D projects. 73% of the projects involved small to medium-sized enterprises. We do work with companies of any size, gargantuan down to single-person startups. But that's quite a large fraction are small to medium size. And we have helped to deploy the next generation talent. More than 1,057 and counting have gained skills and experience being involved with SOSCP projects. More than 552 industrial personnel have also been involved along with those HQP. We're also building an ecosystem with over 290 collaborative R&D projects, and $43 million have been leveraged in R&D investments in those projects as well. Next. So let's shift gears a little bit and start talking a little bit about mining innovation, and how AI, for example, can transform mining innovation. So I have some suggestions, perhaps some perspective candidates where there might be top areas for AI leaning in and transforming mining today. First of these is optimizing operational performance or supply chain, anything to do with operating the mine in a more efficient way, gaining more revenue, making things run more smoothly in multidimensional ways that a human operator, a human mine manager might find challenging, is something that AI can definitely help with. Another area is reducing energy consumption and GHG emissions. This is, of course, top of mind these days and will become more and more important in the future. How to use the energy more efficiently, how to reduce those GHG emissions. In order to do these things, you need to have a really in-depth understanding of the operations in the mine. Third, wearable technologies and Internet of Things, knowing where equipment is, where people are, what they're doing, and making sure that safety is a factor at all times in real time. This is very important in wearable technologies and something that AI can help with. And also human-centered, smart, and autonomous mine design. It's a bit of a bit of a head shaker, but it's true. For all this computing that we may be wanting to insert into mining, it becomes more human-centered if you do it right, and it makes it a better place to work. It makes it safer. It makes it easier. So being human-centered is one of the great features that AI can bring, provided it's designed in the right way. It becomes a better experience for users and for everyone. Okay, I believe we've been kicked out, and or have we? Let's see. Okay, thank you very much. Seems that we're back on track. And of course, finally, attracting and developing and retaining talent. This is very important in the future of mining, making sure that these highly qualified people, the next generation of mining innovators, is brought in, is developed, and is retained. That's an extremely important part, and something that AI can also help it with as well. And to the next slide, please. Okay, and just to wrap up, looking at the time, we should move on. I wanted to just highlight a few different examples of innovation realized where SOSCP projects have led to some positive success stories. Here's one example with PBE Canada. This project was all about fusion and analysis of multi-sensor miner data, and this was using smart computing platforms. So the challenge here is to develop a platform that combines the data from digital wireless, radio, thermal, and video imaging in real time, basically to keep track of the location of miners, where the explosives are, where the vehicles in mines are continuously. And this is something that can be done in real time, which was a very innovative and helpful tool for the mining manager in order to help him or her operate. And this was done with a couple of two different platforms. It's not uncommon to use the platforms that are most well suited to whatever it is that you happen to be doing, calculating or trying to attain. So this one used two different platforms, the cloud and our GPU. The result, the outcome here was the PBE MineBoss 2.0 mine wide tracking system and a proximity alert system, which was successfully the result of this work. On to the next example. Together with our cornerstone partner, IBM Canada, this particular project looked at simulating climate change impacts on permafrost systems. You can imagine how the changing, melting permafrost can wreak havoc with various types of logistics operations. This is a very important thing to understand, and the capabilities to know what's going on in the field, particularly where those activities are taking place, is quite important. And some good outcomes were achieved together in this particular project. Next. Here's another innovation realized. This one's Drone Delivery Canada, which at first glance you might scratch your head and say, what does this have to do with mining? Well, it happens to be a lot, because drones are being used in many different things, from prospecting on down. So how does this drone, where there's no roads, where there's no aspect, a sense of where it is located, how do you get this drone to navigate? So this particular project looked at visual breadcrumbs for emergency return for unmanned aerial vehicles. These are valuable resources, and given weather and various things as you're using them, it's good to be able to track them back to home base. And that was the purpose of this particular project. It's obviously useful in any environment, be it urban, but certainly has special and valued applications in mining. Next. Cisco Mining Corporation, they did a fusion and analysis of multi-sensor miner data using smart computing platforms. So the challenge here was to use cloud computing to automate, represent, and analyze data sets to improve geologists' work and reduce the time and cost of compiling GIS maps, which is clearly quite important. And we had some good results come out, good outcomes come out from this particular project as well, including Java implementation of hill shades and canny edge detection algorithm in this particular case, shuttle radar topography mission data. Okay, I think that's all. If you do have information or do have interest in contacting SOSCP, want further information on how you might use our advanced computing resources, or you want to explore ways that you can work together with a partner and perhaps realize some of the good outcomes of your own, please do give us a call, or rather I should say, please apply at soscip.org. Okay, thanks for your attention. I hope that was of some use and of some interest to everybody. Now, I'd like to go ahead and introduce Charles Nyabeze. Charles is the Vice President of Business Development and Commercialization at the Center for Excellence in Mining Innovation, or CEMI. I almost never say the full version of that. It's always just CEMI. So Charles, beyond his charismatic persona and infamous reputation in mining and elsewhere, Charles leads CEMI's Commercialization Support Services division and is responsible for the identification and securing of opportunities to help clients close the commercialization gap associated with introducing new technologies into the mining value stream. He's also involved with Canada's Mining Innovation Commercialization Accelerator, or MICA network, which has just announced its pan-Canadian call for proposals. So I thought I'd just kind of put a plug in there for you, Charles, before you give our presentation. Can I invite you to do your presentation now, our keynote?
Okay, thank you, Tibor. I'm just going to share my screen. All right. Hey, Tibor, maybe just do a sound check. Can you hear me okay? Can you see my screen?
All good, Charles. Looks good.
Excellent. Thank you. Again, thank you, Tibor, for inviting me to speak. And I just want to say bonjour, everybody across Canada. I'm so glad to be able to share with you some thoughts on our industry and how we can make that connection between mining and advanced computing become more apparent, kind of just flush it out so that everybody can see it more clearly. But before I jump into the presentation, I want to acknowledge where I am. I am in Robinson Huron Treaty Territory, and the land on which I am in right now is the traditional territory of the Atikomaashang Anishinaabe. What I want to do is start off by sort of enrolling you into a conversation. Look, I am totally biased in that I love mining, So everything I say about mining comes from that kind of viewpoint of somebody who's totally sold out to mining. The world as we know it right now depends on mining. I think all you need to do is look around you and sort of make that acknowledgement. Not only is the world dependent on mining today, but it is a generational dependency. And I've sort of looked at mining now as an existential resource. You know how people talk about climate change as an existential threat? Well, mining is that existential resource that we need. We cannot live without it. So we all have phones, we've got computers, we've got lights, cables, electricity, etc. And all things are brought to us courtesy of mining. There's never been a time in history when there has been so much demand for technology, minerals, and metals as we have right now. So things like copper, which is supposed to double in demand for copper, lithium, cobalt, and nickel. Mining is a primary industry. And I like to say to people that, again, totally biased, that mining is the god of all industries, that all the industries sort of depend on mining. But I will acknowledge, though, that advanced computing is something that we all need. Without advanced computing, we would not be able to be speaking together right now. So kudos to advanced computing as well. Mining is a multidisciplinary business system. It's a multidisciplinary industry system as well. Mining is no longer just about mining. The demands of the low carbon economy are causing us all to think about sustainability in different ways. And mining needs to do what it does in a cleaner way. There's a surgence of clean technologies out there that can all support mining. We all know that when you truly calculate the true cost of, say, carbon on any product, you'll see that when you roll all the way back to where the resources are coming from, that we must responsibly source these inputs that are going to create the future that we're all looking for. Canada and the United States have recently made a list of minerals and metals that they're calling critical minerals. The world is resource hungry for minerals and metals. This is why we've got those critical minerals. There's a large portion of this world who don't have what we have, right? They don't have the fridges and the stoves and the toys and the gadgets, the ATVs, snowmobiles, etc. They want these things as well. And the only way they're going to get all these things is that if we produce more minerals and metals. So you may be wondering, well, what does all this have to do with advanced computing? Beginning with the end in mind, here's what we want to do. I would like to connect the resources, capabilities, and assets and opportunities in advanced computing with what's happening with the mining value creation ecosystem. So the mining value creation ecosystem, if you think about it end to end, it's not just that hole in the ground that is mining. Mining is a whole entire process, starting all the way from prospecting, exploration, all the way to rehabilitation and repurposing. So what I'm going to do is I'm going to connect the dots between these components of mining and advanced computing. And hopefully by the end of our presentation, some people, most of us can walk away with that aha moment of seeing where those connections are. But before I jump into connecting the mining value creation ecosystem to advanced computing, I want to start off by introducing you to CEMI and to MICA. So let's talk about CEMI. CEMI, 14-year-old organization, will be 15 years old in May. We are a teenager. And we're a not-for-profit organization governed by board of directors. We are in Sudbury, Ontario. Sudbury happens to be one of those places on the planet where mining is on everyone's tip of everyone's tongue and underneath most people's houses. The vision for CEMI, sorry, not MICA, I'll get to MICA in a moment. For CEMI is to solve the challenge of the mining industry by making the future happen tomorrow. I like to say, make the future happen today. The mission for CEMI is to advance innovation that will help the mining industry to positively impact its triple bottom line. CEMI has structured itself into sort of 4 core services: innovation scouting, challenge identification, challenge solution matching, and commercialization services. Under commercialization services, we are aiming to close the commercialization gap, an area that I coin as the commercialization valley of death, a place where good ideas literally go to die. So MICA was created to close that commercialization gap. So let's talk about MICA. So MICA has 6 main partners across the country, and I'll get back to that in a second. We did launch MICA in November of 2021. It's a 5-year program. It's a national network headquartered in Sudbury with 6 main partners, which are BRIM in British Columbia, Innotech in Alberta, Saskatchewan Polytechnic in Saskatchewan, of course, Mars and CEMI are sort of looking after Dalhousie, Ontario, MISA in Quebec, and the College of North Atlantic in Newfoundland, also covering New Brunswick and Nova Scotia. The territories, Yukon and the Nunavut, are being addressed by those provinces that touch them. MICA has a membership model open to SMEs, mining companies, others, institutions. We were funded by the government $40 million by the Department of ISED. Thank you to the Government of Canada. This funding we will leverage to $112 million through projects. Great news. We recently launched our first call for proposals, and it's open right now. And it will be closing March the 7th. So go on our website and see if there's something there for you. MICA has 3 core service areas or 3 core activities that we'll be doing. Number 1, we'll be offering commercialization support services. Number 2, network development activities and technical projects. Let's talk about technical projects. Under technical projects, we're looking at them under 4 different technology themes. Productivity, we were looking at increasing mine productive capacity at lower costs. We're looking at energy reduction and energy consumption, making sure that we are using energy in the most efficient way possible with the second theme. And then the third theme is smart digital autonomous digital mining systems. We're looking to make mining as smart as humanly possible. We need advanced computing for that. The last technology focus area is environment. We were looking to reduce the environmental risk and long-term liabilities associated with, of course, mining. Let's talk about the mining value creation ecosystem. So MICA, with its productivity, energy, smart environment, is looking to advance technologies that will impact mining in these areas that I'm calling the mining value creation ecosystem. So again, you can see that from mine financing all the way to rehabilitation and repurposing, there's all these different boxes. So what we're going to do now is touch on each of these boxes and sort of give you a bit of a flavor of what's truly happening in these areas. Remember what I said earlier, mining is not just a hole in the ground. Mining is such a complex system of businesses systems that are integrated to create what we call the mining industry. Let's talk about financing and evaluation. Look, mining needs money for mining to do anything that it does. And this money needs to be raised from the investment community. So some of the activities that are happening to secure that financing is looking at those exploration results, looking at environmental impact, sustainable mining, and I do have other things on the list that I'm not going to touch on, but certainly you can see there's a connection with advanced computing when it comes to things like financial computing, financial models, financial risk modeling, etc. Let's jump on to prospecting and exploration. By the way, Canada happens to be a global center for mine finance. So there's so many exploration companies that are listed, not only on the Toronto Stock Exchange, but also in British Columbia. Under the exploration area, the drill results are important. The geology is important. Commodity prices is important, market demands, and all this information needs to be correlated to give the best results possible. Mining produces a lot of data. This data can be converted into useful information by taking advantage of these advanced computing resources. Things like resource modeling, resource targeting, resource estimation, mapping, etc. come into play. Jump onto permitting and consultation. We need permission in order to open mines. And that permission is driven by information that needs to be accurate, timely, and trusted information. So we are looking at activities like environmental impact, exploration permits, mining permits, building permits, etc. There's even an instrument called 43101, which is a very common instrument in mining. And again, if you look at advanced computing resources, we look at those impact modeling type and also trust. We look at the blockchain working, those digital certificates working, risk management has to be done. But again, there's so much information flowing that we need advanced computing resources to make this information flow. Another area is mine design, because mines need to be designed before they get constructed. So under the design side, there's infrastructure requirements, mine plant facilities being built. And again, there's a lot of information that is moving in the design stage. Things like digital twinning, design simulations come into play. Look at mine construction. And mine construction, I'm looking more so at building the infrastructure around the mine, not the mine itself, just the infrastructure around the mine. So there's a lot of logistics considerations, supply chain resources, building of the mine plant and facilities. All this needs to take into consideration. But again, you can see that there's an advanced computing resource that can come into play here. I'll take a moment here just to say one quick statement. If you follow the data all the way from exploration to mine closure, you can actually follow the data all the way along. So the information that you gather during the exploration and permitting phases, all that information comes to play at mine construction. So the information keeps flowing and keeps building up in volume. Let's talk about mine development. Another mine development, I'm talking about building the actual infrastructure of the mine itself, not the support infrastructure. Here is where that hole in the ground comes in, when you sink a shaft to be able to access where the ore bodies are. Tunnel development, drift development has to happen. Things like open pit construction happen, and a bunch of other constructions need to happen in the mine itself. And again, things like digital twinning, digital simulations, and modelings need to come into play. And in this area, things like looking at the condition monitoring of the equipment that you're using needs to start to happen. Look at mining operations. And the reason why I put mining operations is I want to talk about the people. You have to hire people. You have to link the right people with the operation. There needs to be training. Health and safety comes into play. Just to talk about safety for a moment. I recently heard from one of my one of the vendors that I talked to that there's days of the weeks where most accidents happen in a mine. It's even correlations with the full moon on when people have most accidents. All these correlations are being made through advanced computing resources being employed into mining. Things like shift scheduling come into play. Things like support extension of utilities, communications infrastructure, all these things come into play as you're putting that operations piece together. Next, we talk about mineral extraction. This is what I think most people call mining, right? People call mining the process of kind of taking that rock out of the ground and kind of having it, right? That's, people call that mining, but really it's just the mineral extraction piece of mining. And again, here is where you get the drilling, the cutting, the blasting, the material movement, things like material sorting are happening, surveying. There's a lot of activities happening in here. And I mean, the list can go on. But there are advanced computing resources that can be correlated to these areas in things like systems analysis, design simulations, things like predictive maintenance and condition monitoring of equipment come in. Edge computing is coming in as something that is very useful for mining as we're moving towards autonomous mining or automated mining. Next, let's look at mineral processing. So mineral processing is that whole process of beneficiation when you're actually loosening that mineral or metal out of that host rock. In this area, it is probably the area where most of the energy is being spent in the mining industry. And in this area, you've got things like the secondary crushing, the grinding mills, the mineral liberation, smelting, furnaces, leaching, flotation. There's all this work being done to extract that metal or mineral out of its host rock. And in this area, there's advanced computing resources that touch on things like process controls, simulations, condition monitoring, predictive maintenance again comes in, digital twinning comes in, keeps coming up. Things like chemical analysis and more. The list can go on. You know, one of the things I was talking to Tibor about is that maybe we should even have a session where we specifically drill down and ask that hard question. Where exactly in mining can some of the advanced computing resources be employed by doing things like maybe we can do focus groups, working groups to really drill down and figure it out. Let's talk about reject materials. So why did I call them reject materials? Well, the word tailings and waste seems to underplay the true value of those reject materials. Let's call them residue materials because that's what really they are. They are kind of the byproduct of mining. These byproducts of mining need to be stored in a permanent way sometimes, but they can also be reprocessed and they can be repurposed as well. There's a lot of monitoring happening as well when you look at those reject material storage sites. But what we do want to say that is that advanced computing has been helping and is going to help more and more in creating things like early warning systems, things like digital twinning, impact modeling, even like the weather modeling comes into play as well in this area. Risk management is another one as well, because we don't want those accidents that have happened in the past to happen again in any way. Next, let's talk about mine closure. So you know that a mine has a life. Most mines have all mines have a beginning and an end. Unless if you're like running a salt mine or a potash mine, those can last for hundreds of years. But most mines have a mine life that can be 20 years, 10 years, or even less. Under the mine closure activities, there's remote monitoring happening. water monitoring and management. Those reject materials that I spoke about, some of them are permanently stored, so they may need continuous monitoring to make sure that they're staying where they're supposed to where we want them to stay and not move into the environment. And again, if you look at the advanced computing resources that are attached to mine closure, you've got those things like environmental modeling, impact modeling, tracking systems, and risk management. The last area I want to look at under the mining value creation ecosystem, before I touch on some benefits, is rehabilitation and repurposing. And again, in this area is when the mine is closed, what do we do with the next, right? We want to clean up the area, plant trees, reintroduction of species, permanent monitoring. But I also want to touch on some of those repurposing of mining assets, such as, for example, energy storage in those tunnels underground, greenhouses underground in more secure locations for sensitive growth, and things like using those open pit mines for artificial lakes that can be used for fishing if they're done right. They can also be a tourist attraction. I think the folks over in Timmins are actually looking at using some of their open pit mines as tourist attractions. Those reject storage sites can also be used, can be covered by solar panels. Old mines can be used as test beds for research. They can be used as place for demonstration projects. And again, that really opens up a plethora of advanced computing resources once we start to repurpose those mine sites. But we do see things like environmental impact modeling happening, and where energy is being used or stored or being created on those old mine sites, things like energy management systems come into play in this area. So it's a couple of conclusions. I think I've got about 3 slides for conclusions. So the first slide is this: where are the opportunities in mining for advanced computing when you look at the mining value creation ecosystem, which is the whole of mining, beyond that hole in the ground sort of thinking that's out there, right? We got to change the mindset on how we think about mining, change the image of mining. So here's some of the opportunities. Mining produces good data, right? It produces lots of structured data. And I think we all like to work with data that is structured. Probably a little bit easier to work with. Mining is systems oriented. It's a connected system. Mining is process oriented. Kind of lends itself to kind of automation and to further analysis and to optimization. Mining is connected systems, end-to-end connectivity. Mining needs process and whole system optimization. And mining needs sound decision support systems that are knowledge-based, that are evidence-based, because you cannot afford to make the wrong decisions in mining because people's lives and assets are at risk. Mining is getting more and more connected. And in fact, there's a lot more faces that are being put on a lot of this mining equipment and tools, putting a digital face to them. Sensors, there's so much sensors that are being infused into mining. So every year that goes by, I just see the mines creating more and more data. However, mining is not getting enough value from existing data. This is why we need your help, those of you in the advanced computing community. Necessary skills. Mining does not currently have the necessary skills to take full advantage of the advanced computing resources that are out there in order to really put efficiencies into this mining value creation ecosystem. We're going to need data scientists, data engineers, we're going to need analysts, software engineers and programmers, developers. We're going to need process engineers. We need systems engineering. And also we're going to need people with those specific machine learning expertise that we can bring into the mining sector. And this is going to be my second last slide. Talk about the mining of the future. Again, the mining of the future is going to be transformation of that entire mining value creation ecosystem. Mining is not just that hole in the ground. It is more, right? It is all the way from financing to rehabilitation and repurposing. And there's so many things happening across this entire system. In fact, each of these boxes in green is in itself its own ecosystem of activity. So what do we see in the mine of the future? Less people in unsafe work. Predictive maintenance is going to be a norm in mining. Already is. It's starting to happen, although just a few of the elite companies are using it. Improved reliability. Mining has been sort of said that it's too variable, so we're going to make it more reliable. We want to have things like real-time environmental monitoring, machine-to-machine enabled automated and autonomous vehicles. We want to have that in-field drill hole targeting, real-time ore reserve forecasting and modeling, and quantum sensors are coming in as a new thing as well. Don't know a lot about it, but I do know that accuracy of information is going to increase with quantum sensors. Edge computing is starting to happen because we can't afford to deploy an airbag using, with the latency that's there. You need that information now. We're going to looking at integrated production models and simulations. Real-time process optimization is starting to happen, and we need more of it to happen. And digitally enabled and responsive personal protective equipment is important. So the clothes that people wear, the helmet that they wear, the boots that they wear, all this needs to be digitally enabled and digitally connected. The last thing I want to mention is that mining is moving towards what we call selective surgical mining. And I'm borrowing this from my friends at Nova Mera, okay, because they've got that technology that is going to be surgically extract resources in a way that has never been done before. So I'd like to thank you all for listening to my presentation. But before I pen off and ask Tibor to come back, I want to remind you that MICA has its first call for proposals open right now, and the closing date is March the 7th. So I don't want anyone out there to miss that date. It's an important date. So Tibor, I'm going to end my sharing and hand it back to you. Thank you.
Okay, thanks very much, Charles, for that excellent presentation. We appreciate the kind of the perspective that you brought and kind of the various angles of the mining sector.